Hello everyone. So today we'll start a new chapter, that is circle in coordinate geometry. So we'll discuss the properties of circle in a coordinate geometry. That first of all, definition of circle. So what do you mean by circle? That we all know that this is a circle with the radius r, with the radius r. Okay, and here this is the center. I named it O, and I put the coordinate here hk. Here one point is there. This is moving point actually, called pxy. Now definition of circle is actually the set of all point. This is the moving point. This p is the moving point here. Now this is a set of all point in a plane which are at constant distance from a fixed point O. Okay, so this p point actually moving by keeping the constant distance, with the point O. That constant distance is nothing but r. Okay, constant distance is nothing but r. Now O is the center here, and r is radius. O is center, but O having the coordinate hk, and r is here, that is radius. Okay. Now how we can generate the equation of circle? That is, here pxy, we can say that pxy is the arbitrary point, right, in the circle, and O we have the coordinate hk. Now OP radius r is always same, because if you take this point p, and here I take another one point that is called q, and suppose the name is x1 y1. So again, if I draw the line here, this distance will be always fixed, and this distance nothing but r, right? So this distance is actually fixed here. That means OP here, OP is nothing but radius. OP is radius. So mod of OP, that is the distance, equals to root under. Definitely the distance formula will apply here. What is the distance formula? Pxy and OHK. So x minus h whole square plus y minus k whole square, right? And OP equals to r, so you can write here r equals to, or you can write r square equals to x minus h whole square plus y minus k whole square, right? So we'll get the equation of circle. So we'll get the equation of circle with the radius r and having the center at hk. So center at hk and with radius r. So if the center is, for example, the center is 3, 2 and radius is 8 unit, then what will be the equation of the circle? So our equation will be x minus 3 whole square plus y minus 2 whole square, this equals to 8 square, and hence if I evaluate, it will be x square minus 6x plus 9 plus y square minus 4y plus 4. This is equal to 64. By calculating, we'll get x square plus y square minus 6x minus 4y equals to 64 minus 13, or you can get here 51, right? So hence this is the equation of the circle. Now if the circle pass through the center at origin, if the center is at origin, here I can write that if the center is at origin, then what happened? That means this is the coordinate axis here, suppose, and we have one circle with the center at origin. Okay, so what happened here? That is, this point is nothing but 0, 0 point, and here one moving point, that is pxy, with the radius r. That means this distance is, suppose, r. Okay, I'm writing here this is 0, 0. Okay, so we can use the same formula, that is x minus x1 whole square plus y minus y1 whole square. This is equals to r square, the previous formula, or x minus h whole square, this formula I'm talking about. Okay, so here h equals to 0, k equals to 0. So h equals to k equals to 0 here. So the formula became x minus 0 whole square plus y minus 0 whole square. This is equals to r square, or we can simply write that x square plus y square equals to r square. Hence this generates a equation of the circle with center at origin and radius r. Now if, one more thing that we need to discuss here, if one circle is given to you and the diameter is given, here one diameter, this is the diameter, and this circle passes through this diameter passes through the origin, this is, suppose, whatever it is, and this diameter have the endpoint a and b. That means if two point on a circle is given, or a circle pass through 2 points, then how can we find the equation of the circle? That is the thing. Okay, for this we need to know that one property of circle we have, that if I join these two, any point we take here pxy, any random point we'll take here, that is called pxy. Okay, now you can see that this angle, what about this angle? This is the angle in semicircle, isn't it? That AB is the diameter here, and if I consider the arc, APB, this arc is a semicircle, is semicircle. Hence, you can say that angle in semicircle, angle APB, is definitely 90 degree, or you can say AP is perpendicular to PB. So this thing definitely holds. After this one, we need to find here that A having the coordinate, we imagining that A having the coordinate here x1, y1, and B having the coordinate here x2, y2. That is the 2 point will be given to you. That 2 point will be given to you. Now, AP is perpendicular to PB, hence we need to evaluate here one more thing. That is the slope of AB. Slope of AB. Sorry, not AB, AP. And another is slope of PB. Okay, so if this slope we can find out, and we know that these two are perpendicular, then by the relation of the slope in the perpendicular line, we can generate that equation of the circle. So what will be the slope of AP? Slope of AP definitely will be y1 minus y divided by x1 minus x. And slope of PB will be definitely y2 minus y divided by x2 minus x. Okay. Now this one I consider that, suppose this is equals to m1 and this is equals to m2. By the property of straight line, perpendicular straight line, I can write what happened. That is m1 into m2. This must equals to minus 1. This is the straight line. This is the general property of straight line. That if two lines are perpendicular to each other, then having the slope m1 m2 respectively, then what happened? That m1 is to m2. It is equal to minus 1. So alternatively, we can write that y1 minus y divided by x1 minus x into y2 minus y divided by x2 minus x. This definitely equals to minus 1. Or by evaluating, we can get y1 minus y into y minus y2. This equals to, plus x minus x1 into x minus x2. Here this will be y1, y minus y1. This one must be y minus y1 into this one. This is equals to 0. Okay. By taking the simple calculation, we'll get this result. So after getting this result, we can say that if 2 points are given for a circle, then we can generate the equation of the circle. Right? Suppose we have one circle here, and having the diameter, and these points are AB, and these AB points are given. That is, one is 3, 2. Randomly I'm taking. Another is suppose 2, 8. Okay, 3, 2 and 2, 8. These 2 points are given to you for the circle. Not 2, 8. You can take 5, 8. 3, 2 and 5, 8. These 2 points are given to you, and this is the circle. So you need to find out the equation of the circle. 2 points are given. So A and B both lies on the circle. Clear? And hence by this formula we can say that the equation of the circle is equals to y minus y1. So y minus 2 into y minus y2, that means y minus 8, plus x minus 3, x minus 5. This equals to 0. By calculating, we can say that y square minus 10y plus 60 plus x square minus 8x plus 15 is equals to 0. Or we can say x square plus y square minus 8x minus 10y plus 31 is equals to 0. So this is the equation of the circle. Okay. This is how we can find the equation of the circle. Now one more thing that we need to discuss here, that is general equation of circle. That is the general equation of circle. What is the general equation of circle? General equation of circle is actually by taking x minus h whole square plus y minus k whole square. This equals to r square. If I evaluate this one, so after taking after breaking all the square, we can get an equation like this. That is nothing but x square plus y square plus 2gx plus 2fy plus c. This is equals to 0. Okay, where we consider here that h equals to minus g, k equals to minus f, and c equals to we can consider that h square plus k square minus r square, that we have considered. After that we'll get this equation. Okay, that is the general equation of circle. You can evaluate this one after considering this formation, after considering these things, after considering this and this, we can easily say that this is the equation of the general equation of the circle. This is the general equation of the circle, where this minus g and minus f represent the center, and root under this g square plus f square minus c is radius. Okay. this d square plus f square minus c definitely greater than 0, definitely should be greater than 0. Then only the circle is possible. Here some properties is there, that is the equation of circle is actually second degree equation. You can see that the equation of circle, some properties are there. That is, equation of circle is actually a second degree equation. A second degree equation in two variable is second degree equation in two variable, and there is no xy term. You can see in the equation there is no xy term, and definitely the coefficient of x square equals to coefficient of y square. This thing is very important, that coefficient of x square must equals to coefficient of y square here. Then only the circle is possible. Okay. So these are the basic things. Now some deductions are there. There is some important results are there. That is, find the equation of the circle with center hk and touching the x-axis. So if the circle touch the x-axis, then what happen? That is very well-known result and very important also, because in the differential calculus, in the differential equation, we use this result for finding out some problem. So if one circle we have and it touches the x-axis and center at hk, okay, it's center at OHK and touch the x-axis with radius r. Now you tell me, if this one, if O having the coordinate hk, then what will be this length? What will be this length here? This length. This length definitely equals to k. So here k equals to r. Here k equals to r, because this portion is represent h. This portion is actually represent h, right? So definitely this portion represent k. This portion represent k. So k equals to r here, because this is represented the radius. Okay, so k equals to r here. Now putting the values here, there is equation of the circle, that is circle x minus h whole square plus y minus k whole square, this is equals to r square. Now if I put the k equal to r, then what happens? Then x minus h whole square plus y minus r whole square, this is equals to r square. Or you can put r equals to k also. Okay, you can put r equals to k also, that would be better. So here we'll get x square minus 2hx plus h square plus y square minus 2yr plus r square, this is equals to r square. So this r square will be definitely cancel out. So we'll get x square minus 2hx plus h square. Or you can write like this also, that's the general form, x square plus y square minus 2hx minus 2yk. I am putting here r equals to k, this equals to 0. So this is the equation with when it touches the x-axis. Now if it is touch the y-axis, then that means the figure will be look like this. If it is touch the y-axis, then the figure will be look like this. Right? And where this one is represented the center r, and this is the O having the coordinate hk. Now if this one is hk, definitely this portion represent, this portion actually represent h, right? So this will be definitely k. Here, sorry, this will be k and this will be definitely h. So here h equals to r. We can say h equals to r. Now by the symmetry, we can say that the equation will be x square plus y square minus 2ky minus 2hx plus, here 1h square is there, 1h square is there, plus here will be there will be the k square, here there will be k square, is equals to 0. So these are the two important results. That is, one is for the circle touches the x-axis, another one is the circle touches the y-axis. So these two results are very important. So this is all for today. We'll see you in the next session.